is McKenna, and I decided to do my study on the visual properties of craters. As we know, the moon is riddled with them. The Earth has approximately 150, though our atmosphere erodes many of them away, so it's possible that we had the same amount as the moon. We usually think of craters as places hit by meteors, meteorites, etc., but there are many different kinds and each have their own characteristics. The different types are explosion craters, mares, volcanic craters, subsidence and pit craters, Macteshes, and impact craters. Explosive craters are formed when materials ejected from the ground by an explosive event at or just below the surface. The different properties physically are the height of the rim, amount of ejecta projected from surface, which is just, the land and rocks, erosions, landslides of the crater lip and wall as well. These physical properties depend on the height above or below the ground at which the explosion occurs. Mares are broad volcanic craters caused by a phreatomagmatic explosion, which is groundwater coming into contact with hot lava or magma. Mares are large but shallow and flat-floored, and commonly filled with water to form natural lakes. The low rims are composed of loose fragments of rock and rocks torn from the walls of the crater. Volcanic craters are circular basins that contain vents for magma, gas, etc. to escape. Some fill with water and become lakes like mares. They sit atop mountains, usually at the summit, but sometimes on the flanks, and they have the breached ones, which are victims of eruptions, explosions, or erosion, have lower sides on the rim in some places, like seen in the picture. Subsidence craters are formed by below-surface explosions, usually nuclear. Many are present in the Nevada test site. The surface sinks into crater formation, like the one on the left. The one on the right is an example of a retarc. If material above the explosion is solid rock, a mound can form, called a retarc, which is literally crater backwards, which sounds like a joke, but that's actually what they call them. Pit craters are related to subsidence craters, but don't have to be. They form from the collapsing of the surface over an empty chamber, like the first picture of subsidence. They usually have a circular opening, a lack of an elevated rim, and vertical walls filled with fissures. Some can be found in Hawaii where they have collapsed, or where magma chambers have collapsed. Macteshes, or maybe it's just Mactesh, but they are commonly known as craters, but are formed through the erosion of the land. They contain deep valleys and steep walls, and they're unique to the Negev desert in Israel. There are not that many of them. I think there are only 2 sites where they exist. Impact craters, the most well-known, but they are defined as any depression, natural or man-made, that resulted from the high-velocity impact of a large projectile. The distinctive mark of an impact crater is the presence of rock that has undergone shock metamorphic effects. Shock metamorphism describes the effects of shockwave deformation and heating, which is caused by the velocity of the projectile as it hits the Earth. There are 2 types of impact craters: simple, which are circular, bowl-shaped, have an elevated rim. Depth-diameter ratio is about 1:5, so they're not as large. The largest simple crater on Earth is about 4 kilometers, which is 2.5 miles in diameter. Complex craters can be up to 460 kilometers, which is enormous. They feature a central peak and generally have a flat floor and extensive inward collapse around the rim. This has to do with my last slide, which is the art piece that I found. I could only find one, and it's not a very well-known artist, but I believe this is supposed to be a complex crater because of the slope and erosion of the outside rim. However, I don't see a very prominent central peak, so that's incorrect. Anyway, that was my PowerPoint, and I hope it was informative.